Gentlemen, welcome. We're going to look at something new. I've only worked on one other of these ever in my amp building career, repair career. This is the als-600. This is solid state, no tune amplifier. This thing runs with the MRF 150s in it. Pretty straightforward basic amplifier for the most part. It's got some pretty cool stuff in it. Most of it does. And I'll be honest with you, I think going forward, because I've got 4 or 5 of these that are here now that I get to go through, I have a feeling I'm going to be working on more of these. I've noticed the amount of Ameritron equipment make a very steady uptick in the amount of equipment that's being sent here for repair. Now that Ameritron's no longer with us, for the most part. They're still selling parts, but I digress. I think I might need to buy one of these just so I can have the power supply sitting here, so it'll save people a bunch of energy and effort and money. So all they got to do is send me the RF deck. This guy was kind enough to send up the power supply unit with it, right? So the problem is not here. It's here. But I'm just saying, if you've got one out there that maybe this is effed off, or maybe this is the only part you have, I might be interested in buying it from you so I could set it on the shelf for future repairs coming up. Just saying. This gentleman also sent the 10-meter board with it. The situation presents itself as this. He bought the amplifier, he brought it home, he didn't have an antenna that would work on the frequency that he wanted it to work on, so he put it into a dummy load. He said he was able to get it to do 300 watts. He put the band board in it for 10 meters. He couldn't get it to do anything. It was putting out way low power, and then he heard a pop, a hiss, and then nothing. He said it won't do anything on all band, anywhere, no matter what. And I went, okay. Well, let me take a look at it. What's the worst that could happen? I can't figure it out. I haven't had that happen yet. So I get it up here. Now, the manual of arms states that we take the lid off and that we go and lift this board up because the RF deck's underneath. But to properly take this off, we have to disconnect the band selector, take the nut off the front, and now we have room to move this around a little bit. Please note the giant 36 ohm or 33 ohm resistor here. This is a 50 watt resistor. This is our input attenuator. So the input for this pallet, this is the pallet by the way, is hidden behind that resistor, if that makes any sense. So down in here is 4 MRF 150s. We have ourselves a 33 ohm resistor going across both poles of the input transformer. Now the input transformer splitter is actually here. The output transformer is very interesting. It doesn't show up very well from this angle, but the face of the transformers are shorted together with a bar that's right here. This side and this side of the transformer are actually seriesed up. And the other thing that we've got going on here that's a little departure from the norm, which if you think about it, it's kind of cool because it saves us a layer of combining or splitting, so we pick up like another 4 or 5% in efficiency. They've taken the center tap of the winding for the output network and they've tapped it and they've brought them to the same potential. It's kind of cool. I've never seen this before. Makes me kind of go, that's interesting. Both of the outputs of the transformer go to one common pad, and then the output RF itself actually goes up to this white wire that then goes through this piece of ferrite, and then we have got a ground wire that attaches here on the board. So it's technically running unbalanced, and then we've got on the top side here we've got our bridge and our bridge adjustment, which then in turn feeds into this circuit over here on the other side that you guys can't really see, that is our overdrive and SWR protection and all that kind of stuff. So him telling me he heard a pop and a sizzle and then no output power, I'm like, okay, let's go look for something that's obviously burned up. So the first thing that I noticed is burned up right out the hop is this capacitor here. this cap here is actually burned. And it's got a hole in it that's right there. Let's see if I can get a better angle on it from over here. I told him, I said, if it running at low output power and then you hear a pop and a sizzle and some noise and stuff, I said, you had another part that was in here failing. And I don't think it was anything he did on his end. I think that this part was on its way down. Right? So that's a 300 volt, looks like 350 picofarad cap. So, yeah, 350 picofarad. But this thing is done. So it became unbalanced, and I'm assumption, that it wiped out all the other transistors. Now, I can't help but notice, but we've got a pretty significant little burn mark over here. Let me make sure I'm pointing at stuff that's in camera view. This right here. So let's change perspective once again. There's quite a bit of little burnt black schmoo that's right here by this transistor. So something is arced over. You see that? So we've had a double failure. I almost can guarantee you that these transistors are toast. So what we're going to do is we're just going to probably pull one off each side, and we're going to measure it and to see what we get. We'll hook it up on the Atlas identifier tool, the analyzer unit, and we'll see what we got. I'm pretty sure that they're just gone to ground. This is opened up, so it caused a significant imbalance on this half of the pallet, because you know that this is a push-pull configuration, but when we do it in this 4 transistor unit, it's push and then pull, or pull then push. So if we have one side go down and then we're only seeing 300 watts, this is where your pop and your sizzle noise came from. And this shorted out, I guarantee you, which probably wiped out these 2 transistors, but with that being shorted out and then this being center tapped like this, I'm sure it drug these 2 down from the imbalance as well. The output, technical words, big words, I hate using these things. The output VSSWR voltage would climb internally on the circuit, and it would cause multiple component failure. So let's go ahead and let's pull. I'm going to pull this one and pull this one and see what the Atlas says, but either way, I'm going to probably suggest that we replace all 4 transistors in here. I have been working with another company, different topic, switching gears. I've been working with another company, and one of the parts that we're trying to improve on is this MRF 150. This is not the best transistor in the world. It was a good part in its time when it was developed 20 something years ago. But today, I feel that there can be possibilities for an increase in component potential. So let's say that I work with a company, they develop a part that goes in here that we could drop directly in here without having to modify anything else in the circuit. Just change out the MOSFETs in here. And maybe instead of it being a 150 watt part, it was a 250 watt part. Right? Just saying. Now, they say 150 watts PEP for this part. It works out to be about 200, but the rating is 150. So if we could put another 100 watts on top of that, and it wouldn't change dramatically anything that's presenting to the power supply. I know the power supply's got about a 30% margin worth of ability to supply more current. Being that I'm in the unique position of where I'm trying to support these amplifiers as a legacy component going forward into the future for all of you guys in the amateur community, tell me down in the comments, do you think it would be worth it for me to develop a new part that we could do a direct swap and maybe get the amplifier closer to a kilowatt? Do you think anybody would be interested in wanting to do that? Leave your comments down in the doobly-doo. I don't know if this is going to come out or not on camera, but you can see that one tab which would be the drain, arced over so hard that it burned half the tab away. So these, I took them out in order, so yeah. Yeah, this is dead. And even if, let's say these parts test okay, I would still strongly suggest that we replace all four. Let's just start over. Let's give it the cleanest slate that we can and move on, right? So this one's registering as a Zener. Let's see what this one registers as. I mean, I'd like to say that, like this cap here, it's got a hole in it and it was smoked, right? But it's still reading within spec. I don't give a shit. It's got a hole in it. I'm going to replace it. Yeah, see, this one also tests as a Zener. I'd like to say that it was a small piece of solder or something that flicked in here, and I personally think that there was so much RF that backed up it arced over, and when it arced over, that was it. It was just done. So and I also don't feel that I'm the first one that's been in here since, yeah, no component detected. All four of these transistors, these FETs are junk, garbage. So I think somebody else has been in here before me. Hence the weird 15-digit number reading that's on these. It's like this one's 15, this one's 15, this one's 14, this is 13. I mean, it arced over heavy. So either something got in there and shorted this out, or that cap opening up is what took it to the grave. I don't know. I know this. I want to pull this board up, the pallet up. I want to inspect everything on the bottom side too. I'll probably do that next. I'll just undo all the screws and tilt it up. Take a look at the bottom side and make sure all the traces are intact. But yeah, it's kind of obvious to me what happened. Shit happened. Pull the board up. Let's take a look at the bottom side of the board real quick. Everything looks shiny and clean. So while I'm here, oh shit, no, it's all right. Everything's fine. So while I'm here, let's try not to lose any of our spacers. We'll get in here and clean up this copper spreader real good. Come on, let's take the thermal compound off the copper. Oh, the joys of doing this job. I love this job. I don't know why I spent the first 2/3 of my life doing other things other than this, because I knew it was going to happen. Just fought it for a lot of years. All right, let me get this cleaned up. We'll be back. Well, this is where we stopped for probably 2 days. Ordered up $400 worth of new transistors for this thing, and I'm getting them overnighted, so we'll probably get them tomorrow or the day after that, and we'll jump back onto this. But I'm going to switch gears, and we're going to go over and work on an Ameritron als-600 now. So yeah, be looking for that YouTube video, but we will be back. So we will see you soon. It's 6 o'clock at night, and FedEx decided to drop this off here. I mean, I paid for literally overnight delivery, and guess what? They got it here, but it's the end of this day. I wish you guys could see what I'm working on right now. I built the coolest thing today. Well, cool for me is relative, I guess, but I was really impressed with it. I'm really happy with what we've got going on. Almost $500 in that little plastic bag. Half grand. 400 and some change to get it here. MRF 150s. It is, like I said, it's late. It's 5:55 at night. I'm getting ready to call it a day, but the parts are here, so I'm going to get out here and jam on this tomorrow. First thing. The other thing I want to take up is I want to look at the band board and make sure there's nothing burned up on the band board as well, but getting these to run is going to be a little bit of a process. We got to reset. I got to check all the gate voltages and stuff before we put the transistors on and blah, 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 blah. But hey, moving forward, getting her done. You know, 2 for the pink, or is it 2 for the pink, 1 for the snake? Let's see how's it go. Yeah, it's like that. Yeah, we're moving on. I'm telling. I might throw a little clip in here, but just awesome. I've built 3 different test pieces with this current product, and I'm just absolutely blown away. I can't say anything more yet. I mean, the guys on Patreon got a snippet video of it today, which they're all like, what the shit? I'm like, hey, told you, cool shit coming. Anyhow, just saying, we'll see you guys in the morning. I swear soldering to some of this MFJ shit is a pain in the ass. Okay, so what we did is we got rid of this 360 picofarad capacitor here at 500 volt, and we replaced it with 2 caps that equal 360 picofarad, and they're at 1,000 volt apiece. So we doubled the kV rating, and then we got rid of the shitty little bar that was here, even though the trace that holds the 2 fronts of this transformer together is a solid piece. They had a bar going across the top, so we're just going to emulate what they had going on. This is something I can recreate over and over and over and over again. I had to make sure I didn't replace it with, like, I don't know, a disc capacitor like this, or the same style of capacitor like this again. I wanted to go with something I never had to worry about. Like, I can put these 2 caps in here and I can totally forget about it, and then if somebody ever sends me their als-600 again to get repaired, other than this guy, like somebody else new, you know, I can recreate this repair for them again. Okay, so because if it's happened once, you can almost guarantee it's going to happen again, right? So planning for into the future. I have a lot of 150s and 225s and 250 caps laying around here. I can recreate that a couple dozen times. These are the new matched pair directly from RF Parts transistors, not from AliExpress, right? So, like, legit directly from RF Parts, you know what I'm saying? What we need to determine is what our gate voltage needs to be, and our Atlas can easily provide us with that information. We just have to understand that this is a maximum voltage. So when we scroll down on our Atlas, believe it or not, there's more than just an HFE gain checker in this tool. It's telling me that my gate voltage, maximum gate voltage, is going to be 3.180 volts. Okay, so write that down, tattoo that on your forehead, put a Sharpie out and write it on the tip of your wiener if you got to do that. So we'll say max 3.18 volt. Now its match partner should be pretty close. This needs to be so precise on this Series 2 FET that they've given us a trim pot for each transistor. So let's see what this says. See, look at that, 2.907. Huge difference in voltage. So we're all going to be around the 3-volt range, I have a feeling. That's these two match pairs. I'm so glad to see they don't bother with anti-static bags anymore with this shit. Okay, so let's grab this set here. .75 and 1. We'll make these right-hand side. 3.11 volts. So this is the 76. 76. Left hand. 3.111. There's a method to this madness, I swear. On. 3.06. Okay, so right all around 3 volts. 3.060. Okay, so now what I did is I've wrote myself a ledger. And what we've got to write this down for. So this is 86. 68, pardon me. I know if I leave this little data tag on here, each one of them's got their own little number on them, by the way. Turn down the exposure. So they've all got their own little number on them. 80s or 68, 76, 75, 1. Now I can go and I can look at my little chart and go, okay, I'm going to adjust this one to, we'll say 2.8 volts, this one 2.8, that 2.8, that to 2.8. And then I can go put the transistors in, and then I can current match each one of the transistors. So we start out low, it's at 2.5 volts, we'll say. Start out at 2.5 volts, we'll start out low, and then I look at the current draw of each transistor to determine its class, and then I can balance them all. That way we have equal amount of amplification coming from each part. This is a little bit tricky to set up, but once you understand what you're doing and why you have to set it up this way, it becomes very simple, right? So now I can take these transistors and move them. And what we'll do now is we'll get this put back most of the way. So I'll put ground here, and I'll give a ground to this, and I'll get it moved over here out of the way. We'll get out our volt probe it up, and we'll bring the power supply up, and we'll actually power this thing up and check our bias voltages and get that trimmed out. And once we get that trimmed out, then we can go and put the transistors back into the case. It's a little bit time intensive. Have to think about what you're doing. This isn't like working on a bipolar box where you can just flip-flop parts all day long. You gotta have a sequence and follow it, right? Procedure. Manual of arms. Reasons for existing. Okay, so let's see what we had in here is their voltages. 3.4, 3.4, 3.4, 3.4. So 3.47, 3.44, 3.47, 3.47, 3.42, 3.48. So knowing that we start out with a 3.4, we go way high, we're down to nothing. So now, shoot, where did I put my notes? About like 6 phone calls and a whole bunch of stuff go on since the last little segment. Where'd I put my roadmap? Son of a gun. It's sitting right here next to me. Okay. So this first one, we're going to trim that to 3.18. Okay, this next one we're going to trim this to 3 volts. Close enough for the girls I go with. And 3 volts. This one here. Let's trim this down. Let's set all of these at 3 volts. I bet we end up at about 3.2, 3.3 volts. But now we got a baseline and we know where we sit. So let's disconnect the power supply, get it out of our way. Let's go rebuild the RF deck. Now let's take a little bit of time. Let's look at the band selector. Okay. End up being 3.2 or 3.35 volts. So we were half a, or let's say hundredth of a volt off with the factory setting, which is not enough for us to be concerned with. So now, moving on, the other part of this equation was he couldn't get this, that, or the other thing with the band selector to work properly, specifically the 10 meter, and he couldn't get it to put out the appropriate amount of power on the other bands. So what I'm looking for on the bottom side to see is if we have any physical trace failure, which we don't. So for me to proceed forward now, I mean, there's no cold solder joints, nothing like that. The band switch is obviously not burned up. So let me throw some more screws in this. And I think we're to the point now where we can go run this, at least like on 180 meter, or pardon me, 80 meters or something like that. So yeah, moving along slow but sure. We're almost to the end of this conversation, I feel. I think that there are some other issues at foot, which we'll talk about here in a minute. But let's see what happens here. Let me, no, don't get cross-threaded. There you go. Let's get this put back together. Let's make sure we got everything plugged in where it needs to be plugged in. And let's give it a whirl on the tilt-a-whirl and see what it does. All right, let's go have some fun now. So, we are currently on the band of the 1/60th, right? This is what we're putting in for it for drive. Hello, 1, 2, about 80, 90 watts. Like 10 watts less than what it's designed to have put in it. This is a 500 to 600 watt amplifier, period. Period. These TMOS transistors, not a fan. Anyhow, hello. So it does 600 watts. 2 spec. Hello. Hello. Audio. Hello. Audio. Wow. It's amazing how a little bit of angle makes that big of a difference on a watt meter. Here, check it out. This is what I'm seeing from my side of the street. Stand next to the camera. Hello. Hello. Like 680 or 580 to me. We'll call it 580 for the sake of sanity and peace and the happiness amongst small, broken children in Africa kind of thing. Okay, so let's now do 80 meters. 1, 1, 1, 1, 1. Hello, 1, 1, hello. 500 watts. Let's go on up. Let's do 40. Hello, 1, 1, hello. 500 watts. Let's see, 20. Is it 14.5? So it's going to be one of these two bands. Hello, audio. 500 watts on that band. Hello, 500 watts on that band. So now the only thing we got left is auxiliary, which is 10 meters. Now in theory this thing should work everywhere, because the way they got the band laid out is 1.5 through 2.3, 2.3 through 4.4, but it does that all the way through. So we got stable operation, we've got expected output power. Let's mod this thing for 10 meters. What do you think? I think so. Hello. Ooh. Interesting. Okay, let's jump back down here to 14 megs. Hello, audio. So we had power and then it fell off. There's something loose? I don't know. That was interesting. Let's go back over to 10 meters again. This time let's not drive it to full fledgling power here. Hello, 1, 2. Hello, nada. Hello. 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 Okay, so we legit have a problem. Houston, we have a problem. Well, let's take apart everything we just did and see if we can figure this out. So in the amplifier, this switch would not conduct anything on the input side. Output side. That's our common, okay? So you have to think of the switch in this position. So that's 160 and that's 10. So we'll go over here to 160. By the way, these are through-hole solder switches, and this was a pain in the ass to take out. So it's 160, right? Here's our 80 meter position. 40, 20, 12 or 15, and then last but not least, Dawson. Oh, I got to replace my alligator clips. I burned them up too many times. Dawson 10 meters. But in the amp, it wouldn't do anything. It's not burned up. Nothing's broke. That's what I was afraid of. I'm like, well, I couldn't get it to conduct. I couldn't get it to pass nothing. I couldn't do nothing. And I'm like, well, I hope it ain't the switch. Maybe I can take it apart and clean the tabs, because I could not get this to conduct a single drop of one snart of any little bit of driblet of jisnum. Nothing. So here's the input side. 80. Stop touching. Thank you. Okay, so 10. Back down through the band. It took an hour and a half to get that band selector out because it was through hole soldered. And then they folded the legs over on the... Now it wants to work out of the amplifier. Boy, that's frustrating. There's no smoking gun is what's got me upset. I can't point at it and be like, oh, yep, that's burned up. Sorry, can't get no parts, moving on. Or, oh, that's burned up, let's fix this part. Or, hey, that transistor, this cap, this wire, this inductor trace bad. All right, well, I'll see you in 30 minutes. I got to put all this back together again. Whatever. This is almost comical at this point. So I just had this all back together. Works everywhere, nothing on 10. the RF is coming out of the amplifier. It's coming up through this white wire. It goes through another wire, comes over here. This is our common. Here's our 10 meter position. On down to the next one. On down to the next one. On down to the next one. So on. So on. So now on the input side, this is our common here to this lead. So now we're back in 10. 10, good to go. On down. Good to go. On down. Where'd you go? There it is. Good to go. On down. Good to go. On down. Good to go. I have no output on 10. I have checked all the caps. I have conductivity through everything. I've checked all the caps here, all the caps on the board. I've got good band movement. I can see the RF coming in. I can trace it through the palette. I can, man. I'm going to stop for a minute and go have some lunch, even though it is 3 o'clock in the afternoon, and I started on this at 5:45 das morning. Simplest thing in the world, kicking my butt. I'm going to grab some lunch. I'll be back later on tonight. Okay, so with our oscilloscope here, we're just going to probe. So we're in the 10 meter position. We're interjecting 10 meters in a very small amount of signal at that. So let's see, I got the probe on 10 to 1. Yep, okay. Of course, foot pedal's right where the tripod leg's at. Okay, so this is our input side. Obviously got signal on the input side. Into the filter board, out of the filter board, to the trace on the switch, yep. To the output, we've got nothing. Nothing. So RF's getting lost in the switch. Straight up, just getting lost in the switch. So I could sit here and take this apart 5 more times, or we're just going to have to understand that there's something internally wrong with the switch, that it's just not making contact in the board. It needs a replacement switch. Well, it's not too late in the day. Let me call Ameritron. Let's see what they've got sitting on the shelf, if anything. Oh, my friend Tech9. I got to tell you, you guys, this amp, I couldn't figure it out. Like, I've had the band switch out. I've done all this stuff. You guys are watching me do all this stuff, but there's been like 16 times that's went on in the background. I'm like, man, I promised this man. You have no idea how long it takes to take each one of these through-hole soldered caps off, along with the band switch, and then all the caps that have anything to, because I very quickly have figured out that there was a short. I thought that I wasn't getting any connection between these 2 points and these 2 points, but I was, but it was showing up as a short. So I'm like running the whole circuit, pulling this apart and looking at that, and I'm sitting there on the phone with my friend Tech9, and we were BSing about the digital watt meter. By the way, the digital watt meter works awesome. It will be returning to the venue here shortly. I was running it. I know I don't have anything plugged into these watt meters, by the way, right? There's no power wires. There's no mystery anything hooked up to anything here. If I do that, which would be awesome, because if you knew how many 9-volt batteries I go through, I'd love to have an external power wire running off to power my meters, but the knee-sayer bleacher creatures come along and, oh, look, he's got wires attached. He's adjusting a knob off camera you can't see. I'm telling you, I've heard this. I was explaining to Tech9 about that digital meter. I said, man, I ran it till the battery went dead, and I was right in the middle of a project. So I reached over and pulled the digital meter out, set it on the shelf, grabbed the old analog one, put it back in its place, and went on with my project. Plugged in the digital meter, which is sitting right here, by the way, and it's got a brand new set of firmware in it that I've got to do a YouTube video on. This is the BBI firmware I was informed of yesterday, version 4. And the reason he named it BBI's firmware because I refused to update the firmware. He called me yesterday, just yesterday, asking me about this meter. Where'd my meter go? Is it okay? Everything working all right? Yes, the meter's working great. This is the coolest watt meter ever. It has an external power plug on it for charging. It's got a committed plug on the inside that you can hook up 12 volt to, or anything you want. It'll run on like 1.5 volts through like 40 volts or whatever. It's amazing. This is an amazing unit. I don't have any of that shit hooked up because I don't get to have any of that, because if I had a wire hooked up to this and it ran off camera, somebody's going to say I'm making it lie, right? So, but no, the meter's fine. Just thought I'd cover that real quick. So anyhow, this amplifier I feel like has kicked my taint in. I couldn't figure it out. I'm like, why, what? I'm checking everything. Multimeter, jumper, oscilloscope, sticking a finger in my nose, pulling it out, sticking it in my ear, shoved it in my belly button. No brown stuff came out, so I don't get to relabel my belly button, my butthole, or none of that crap. And I'm sitting here looking at this board. And I'm like, okay, well, we have the 2 inductor coils and the 2 caps, or the 4 caps. I should be able to just go and take my voltometer, and as I'm talking to my buddy Tech9, and we're talking about the meter and stuff and things and ideas and emotions and words, I took the voltmeter and went, wait a minute. What? And I went, what am I missing? I flip it over again, I look at all the caps. Now please note, I've had the soldering iron on each one of these cap legs, and I've popped these caps out, and I've flipped this around about 35 times today. Some days I just feel like I'm a high-functioning moron. Well, not all days I actually feel that way, but... You ready? It's right here in front of everybody. Ready? So the board is ground. Most of the board is ground. So what happens if you take the coil when it's assembled directly from Ameritron and it's laying down on the ground? So the RF comes in on this port. It comes out on this wire. It goes around a little hoop, and then it's laying directly against ground. Look at that. You can't see behind the coil because it's touching ground. Now, I literally was on the phone. I was like, dude, I feel like an idiot. Watch. This is such an easy fix. Ready? 1, 2. Nice little air gap. This has been every single thing I've tried to work on today. And I feel like every person I've interacted with today, somehow I've managed to piss them off at some level or another. Okay, it's out of my system now, and I've brought you all up to speed. 1 1 1 1 1 1. Hello, 1 1 1 1 1 1 1 1. Hello, 1 1. Try it in the 32 volt setting for the RIDI, which is low. Hello, 1 1 1 1 1 1. Isn't that amazing? So there's a low power switch here, low voltage. Okay. That's for RTTY, RITA, which is full pulse all the time, just like trying to run FM or CW. Hello, one hoop, about 380 watts versus hello. Like I said, transistors aren't the greatest in the world, but hey. All right, let's throw the tin on it. I want to see it make some heat, and I want to get some key down time on it. So power off, case on, baby, Case on, baby. Okay. So we're going to put it in the hardest mode of operation. We're going to put some time on this. So, let's see, I need a rubber band. This is a cool little amplifier. Very simplistic design. Very, very simple design. Nice, clean, half a watt, or half kW worth of time, right? So we're going to reset this. And so I've got the input power dialed back to about half. So I'll hit start. There's 500 watts full chooch. Now you never want to run like that on FM. You'll break everything, right? Because it's full, sinusoidal full load all the time. There's no peak envelope, there's no rest for the transistor, it's full on. So we're going to run it at half. A 200 watt, 210 watt carrier somewhere in there, as we can see. Meter on the front says 300, but that's not the most reliable thing. The amp meter on the front of this thing shows that we're putting 50 volts at 15 amps into this device. So the heat soak issue is we got to check this out. I mean, you got to remember this has got a copper spreader on it, so we're utilizing a full heat sink. I want to get the temp up on the parts, because me just sitting here going hello audio 11111 and then I'm keying. This allows me to guarantee in my mind, because I don't want to ever see this amp again. I want this guy to be able to use it and have a lot of fun with it. Allows me to understand, okay, we got every transistor tight. Every solder joint is done. There's enough thermal paste on everything. Everything is put back together correctly. The band switches back in. I've had this band selector out a couple times. I mean, this day, you guys only got to see a small portion of it on video. I can't believe I didn't see that coil shorted out. I could have been done with this hours ago. I could have shipped this thing out today. Oh well. Oh well. Okay, so, and off the mic. On key, let this catch up. Now let's go to the other end of things. Go to 180, even though 180 is not, you're not supposed to use FM, or we're going to use it, but that's okay. We're on a sealed dummy loop. Yeah, sealed, completely sealed system. So we're going to go to the other end of the band now. And I love how people say, well, you know, it's a lot easier for them to produce part out. No, it doesn't matter to the transistor. It really doesn't. The transistor could care less. Now, what's the circuitry designed for inside the box? How resonant that is with the part? That's a completely different conversation. But 3, 2, 1. Still says 300 watts on the front. And a little bit less amperage, showing 15.5 amps on the front of this thing. Right here. Yeah. I bet you that the guy was trying to run it on 10. We had smoking gun. We have smoking gun now. The guy was trying to run it on 10 meters. And with that being shorted out, he's trying it and he's trying it and he's trying it. And I bet you that the caps got hot. That's what caused the caps to fail. That's why the transistors blew up. And that was because of that. This part right here. Straight from MFJ. So the suck bit is I got to write off most of this time, right? So I could have been doing other things, and that's my fault. I'm the technician. It's on me. I get it. Maybe next time I don't need to shove the Q-tip all the way in. I only need to put it in that much, not the whole way. My brain would be in a better place. I feel very confident in this amp now. Gate voltage is right. The relays are right. The solder working, it's right. Yeah, we're up to about 100 and maybe 20, 109 degree air. Okay, enough with this. I think we fixed it. So the only thing I have left to do now is to put all the screws in it. So I think I can call this video a wrap. You guys, I've had a lot on my plate the last 6 months. And most of it has nothing to do with anything out here. Some of it has a lot to do with something I'm trying to put together for all of you guys out here. And when I say all of you guys, I mean literally all of radio. The test that I ran the other day was epic. And I'm so excited that the parts finally passed that test. So we'll see what happens. The future is open to all of us. And the only thing that limits any of us is our focus, drive, and discipline. Serious. I believe in that hard. Really, the only thing that limits us is our mental capacity that we were given by God and our ability to focus that down and do something with that capacity. I thank God every day that I get to be out here and I get to work on these crazy things for all of you. And I appreciate every single one of you guys that watch the video, number one. Number two, I thank you guys for keeping me busy and keeping me in projects. I know I'm a little crazy, but then you'd have to be to do this job. So I say thank you to every single one of you guys. This gentleman here, thank you for sending this up. I learned a whole awful lot about this. I now can do this amplifier in my sleep if I wanted to. Assembled from Ameritron with the coil shorted out. Gentlemen, my name is BBI, and without a shadow of a doubt, I say thank you to every single one of my Patreon supporters that make this possible for me to be out here and play / work. Say thanks to every single one of you. Shout out to MechMan, Sigilant, Bird, Coaxial Dynamics. Big shout out to my partners in crime over at Penna Labs, our new friends over at Odyssey, and every single one of you. On that note, it's beer 30. I've had enough. I'll see you guys. Click.